Next is question number 86, which says that the largest term of the sequence 9 upon 65, 1 upon 2, 81 upon 91, 9 by 8 is. Now the sequence can be written as 9 upon 65, 36 upon 72, 81 upon 91, and so on. Here, if we observe it carefully, then we can see that Tn is written to be equal to 9 into n square upon n cube plus 64. This is the nth term that is given over here. Let us assume un to be equal to the opposite of it, that is n cube plus 64 upon 9n square. So this is equal to n upon 9 plus 64 upon 9n square, right? Now, if we have to find the largest term of this sequence, so we have to find the smallest term of this sequence, right? Now, to find the smallest term, we know that we can differentiate it and equate it equal to 0. That is, dun upon dn is equal to 0. So we get 1 by n minus 64 upon 9 into 2 upon n cube is equal to 0. That is, n cube is equal to 64 into 2, that is 128. That is, n is equal to 4 into 2 raised to the power 1 by 3, which is not an integer. Also, d2un upon dn2 will be equal to, differentiating it again, we can see that it will be equal to 64 into 3 into 2, that is 6 upon 9 into n raised to the power 4, which is always greater than 0. Right, now this is always greater than 0. Therefore, at the point where differentiation is equal to 0, it will be minima. Right. So the graph of the function is something like this. That is, at n equal to 4 into 2 raised to the power 1 by 3, we have minima. Right. So we have to find the value at n greater than this value and at n less than this value, so that we can find the largest term of the given sequence. Right. So here it is given that n cube is equal to 128. Now we know that 5 cube is equal to 125 and 6 cube is equal to 216. So the value is lying between 5 and 6. Therefore, we will check the value at both these integral points. Right. So we find that u at 5 is equal to 5 upon 9 plus 64 upon 9 into 25, right? So this will be equal to 125 upon 9 into 25 plus 64. So this will be equal to 189 upon 9 into 25, that is u5 is equal to 21 upon 25, right? This is one value. Similarly, we will find the value of u6, which will be equal to 6 upon 9 plus 64 upon 9 into 6 square, right? So this will be equal to, taking LCM as 9 into 36, it will be equal to 6 cube plus 64 into 9. So here we can calculate u6 also in the similar manner, and we will find that the largest term of the sequence Tn will be obtained when un is smallest, right? So it will be obtained at n equal to 5. So we find that the largest term of the sequence will be 25 upon 21, right? So the correct answer will be option number 1. Question number 87 says that if an is equal to ln2 raised to the power n into summation r going from 1 to n, r upon r factorial into n minus r factorial, where n belongs to n, then sum of the series a1 plus a2 plus a3 up till infinity is, right? Here an is given to be equal to ln2 raised to the power n into summation r going from 1 to n, r upon r factorial into n minus r factorial. Now here, dividing and multiplying by n factorial, we get it equal to ln2 raised to the power n upon n factorial into summation r going from 1 to n, r into ncr, right? Now we know that 1 plus x raised to the power n is equal to nc0 plus nc1 into x plus nc2 into x square and so on. Right? Now if I differentiate it, we get it n into 1 plus x raised to the power n minus 1 equal to nc1 plus 2 into nc2 into x and so on, right? So this is the summation of r into ncr. So this will be obtained when we put x equal to 1. So it will be equal to 2n into 2 raised to the power n minus 1. So let us put this value here. So we will get it equal to ln 2 raised to the power n upon n factorial into n into 2 raised to the power n minus 1, which can be written equal to, in the denominator we will get n minus 1 factorial, and in the numerator we will have ln 2 into ln 2 raised to the power n minus 1, that is ln 4 raised to the power n minus 1. So this is the value of an. Now we have to find a1 plus a2 plus a3 up till infinity. So that will be equal to a1. So taking ln 2 common, 1 plus, putting n equal to 2, we will get ln 4 upon 1 factorial plus ln 4 square upon 2 factorial and so on up till infinity, which is equal to ln 2 into, this is the expansion of e raised to the power ln 4. So this will be equal to 4. So this will be equal to 4 into ln 2, that is ln of 2 raised to the power 4, that is 16. So the correct answer will be option number 4. Next is question number 88, that is, if the equation x cube minus px square plus qx minus 64 equal to 0 has 3 real roots in GP, then let us say it have 3 real roots, that is alpha upon beta, alpha and alpha into beta. Let us say these are the 3 real roots. So we can say that alpha by beta plus alpha beta, that is sum of roots is equal to p, and sum of roots taking 2 at a time, that is alpha square upon beta plus alpha square beta plus alpha square is equal to q, and alpha cube, that is product of 3 roots, will be equal to 64. So from here we find that alpha is equal to 4. Now from here, if I take alpha common, so we will get alpha upon beta plus alpha beta plus alpha is equal to q, right? So from equation 1 and 2, we see that alpha into p is equal to q. Now as alpha is equal to 4, so we can say that 4p is equal to q. So this is the relation that we get between p and q. So the correct answer will be option number 3. Next is question number 89, which says that the natural numbers are grouped as follows: 1, 2, 3, 4, 5, 6, 7, 8, 9. Then the first term of 9th group is, see here we can observe that in first group we have 1 number, in second group we have 3 numbers, in third group we have 5 numbers. Similarly in fourth group we will have 7 members, right? Now we want the first term of 9th group, right? So we can say that the last number in each group is a perfect square. That is, in first group the last number is 1, in second group the last number is 4, that is equal to 2 square, and in third group we have last number is 9, so that is 3 square. So if I talk about 8th group, then on the 8th group we will have 8 whole square at the end, right? That is 64 at the end. That is, at the starting of the 9th group, first term will be 64 plus 1, that is 65. So the correct answer will be option number 1. Now this is the last question, that is question number 90, which says that if r is equal to root 2 plus 1 raised to the power 2019 equal to GIF of r plus f, and f is equal to r minus GIF of r, such that f goes from 0 to 1, where this denotes the greatest integer function, then GIF of r is equal to. Now here GIF of R plus F is given to be equal to root 2 plus 1 raised to the power 2019, right? Now let us assume a value G equal to root 2 minus 1 raised to the power 2019, right? Now this can be written equal to 2019 C0 into root 2 raised to the power 2019 minus 2019 C1 into root 2 raised to the power 2018 and so on. Similarly, GIF of R plus F can be written as 2019 C0 into root 2 raised to the power 2019 plus 2019 C1 into root 2 raised to the power 2018 and so on, right? Now, if we subtract these two terms, that is, if I found GIF of R plus F minus G, so this will be equal to, these terms will get cancelled, so it will be equal to 2 times 2019 C1 into root 2 raised to the power 2018 plus 2019 C3 into root 2 raised to the power 2016 and so on, right? So this is the value of this one. Now here in the right hand side we can see that it is an integer and this is also an integer. So we can say that F minus G should also belong to an integer, right? Now we know that F is going from 0 to 1. Also we see that G is equal to root 2 minus 1 raised to the power 2019, which will also lie between 0 to 1. So we can see that F minus G will go from minus 1 up till 1. So the only integral value that is possible for F minus G is 0. So from here we can say that F will be equal to G. Now from 1 we can write that GIF of R is equal to root 2 plus 1 raised to the power 2019 minus F, right? Now this can be written as 1 upon multiplying and dividing by root 2 minus 1 raised to the power 2019. In the numerator we will get 1 and the denominator we will get root 2 minus 1 raised to the power 2019 minus F, right? This is further equal to, now this is G, so it can be written as 1 upon G minus F, but as G is equal to F, so it can be written as 1 by F minus F. That is, the correct answer will be option number 1. So this was the AIATS number 4 that was held on 2nd December 2018. Thank you.